Welcome everybody to our new installment of the UNESCO Chair in Disaster Risk Reductions webinar series. Today we have a very exciting webinar on the infrastructure resilience initiatives in the Philippines and the Philippine experience in improving infrastructure resilience at national level against the large number of hazards that the country is exposed to. As many of you will know from our past webinars, has now become almost normal that I have an initial slide of what is the latest hit in terms of natural events that affect the built environment. And we have all heard about the latest news on the Hualien magnitude 7.2 Taiwan earthquake that occurred on April the 3rd. The earthquake was the strongest earthquake since 1999, hitting Taiwan, and in this case hit the northeast of the island. And it's given the magnitude of the earthquake and the fact that it was very close, the epicenter was very close to the coast, it is amazing that only 15 people lost their lives. There are still a couple of missing persons and more than thousands were injured. Considering, as I said, the geological magnitude of the event, and in particularly we can land rise of about 8.1 centimeters was measured in and around the Hualien port, and up to 50 centimeters in fault movement. What we have seen, many of us will have seen in the news the pictures on the right of the tilting building. So this is quite clear that there are still, even in a country like Taiwan that has completely changed their approach to seismic design in the last 25 years, there are still buildings that suffers from soft story collapse. In all, the total of building failing in it's about less than 100, and you can see here in the level. So this information comes from the National Center for Research in Earthquake Engineering, and I have a few more elements looking at multiple cases of pipeline damage that were reported to both for gas and water supplies. The transportation, as we know, was disrupted quite highly, both highway and railway, but indeed most of it was restated and recovered within 24 hours. As far as we know, only 4 schools were damaged, were affected by the damage, particularly the National Hualien Girl High School in Hualien was, as you can see, had short column failures and with poor shear reinforcement. And one school in Hualien was also used as a shelter. This is always the type of statistic that I try to give in each of the events. But we have an extra today because one of our colleagues from Taiwan, from Yulin University of Science and Technology, will speak about this at the end of our regular schedule. Meanwhile, I would like to properly introduce today's event. So with all the speakers and reactors and moderators that you can see here. So the first part of the event, in the first hours, after my very brief introductions, we will have Dr. Winston Oreta from De La Salle University, proposing an overview of the ASEP, which is the Association for Earthquake Engineering in the Philippines, talking about disaster management and training programs. Professor Oreta is a professor at the Department of Civil Engineering of De La Salle University. He's a member of the Disaster Resilience Unit of DLSU, Center for Engineering and Sustainable Development Research. He served as a consultant for many UNI SDR projects and development, and he has extensively collaborated with UCL in the past on several projects, which I will very briefly introduce later. Similarly, Professor Alessandro Garciano is the current head of department of the LSU for civil engineering, and he has also actively involved in professional organizations such as the Association of Structural Engineers of the Philippines, and he is also a member of the American Society for Civil Engineers. And we have again collaborated very extensively on past projects in the Philippines, both on historic buildings and school resilience. And he will talk to us about the lessons that can be learned on from damaged structures from past earthquakes. We will then hear from engineer Juanito Cunanan on the government effort to make public building resilience. And he started his career as a public inspector of the Office of Building Office in Manila, and is a faculty member of the Civil Engineering Department of the Rizal Technological University. His DRR initiative started when he was trained as volunteer responder evaluator of the Disaster Quick Response Program of the PAISI ASEP and DRR MSc, and then continuously volunteer in post-earthquake response in the Philippines and Southeast Asia. He has actively participated in lectures on post-disaster retrofitting and chairs the Philippine Institute of Civil Engineer Disaster Risk Management Program. After we will have a 5 minutes break after these first three introductions, first three lectures, and then we will pass to the second part of the presentations of the webinar, where we will have 2 more presentations and then discussion first from our reactors, and then some moderated question and answers. And then finally, we will have the presentation on the Ualian earthquake. As you will see here, the program is slightly extended beyond our ending time of 7 p.m. for the Philippines and 12 p.m. for UK, but I hope that you can stay on and listen to the presentation from Dr. Pierre Mars, which returns directly from the field in Yuan country and in Taiwan. The second part of the webinar will be started off by Dr. Asana Paramal-Vatteri, which is one of the research fellow on the UNESCO chair in disaster risk reduction and resilience here at UCL. We have an ongoing program of collaboration with Xavier University on defining the system interaction between the school system and the road network around the schools in terms of how the rupture of these 2 systems affect the delivery of education. And Dr. Paramal-Vatteri will talk on the application of already established survey methods with the Glossi and Parnassus. She will extend that during her talk on the Cagayan de Oro scopes. And finally, Dr. Rodolfo Mendoza will talk about the restoration of Bantai Church in Vigan. Dr. Mendoza has more than 15 years of professional experience in the field of structural engineering and consulting, and he has undertaken significant both marine projects, but also designs of buildings He has extensively worked on the design of the tallest building in the Philippines and contributed to the structural evaluation and restoration of several heritage structures, now sitting as the engineer expert on the UNESCO project of the Vegan Heritage Emergency Fund. And finally, we will have our reactors, Dr. Ji-Yoon Byun, who's a lecturer in smart, sustainable and resilient infrastructures at University of Glasgow, and has previously collaborated, was a research fellow at UCL and collaborated with the chair extensively. And we will have also Dr. German Velasquez, who's the director of mitigation and adaptation divisions of the Green Climate Fund. So we will also look at that aspects of how we can become more resilient and recovery, not just the earthquake perspective, but also we will have Professor Emma Porio, who's emeritus at the Ateneos of the Manila University and is the principal investigator of coastal cities at risk in the Philippines. And again, we will have a third and very important viewpoint on related to sea raising level and small island resilience. With this, I just, as it's conventional, I just want to very quickly introduce next webinars. So we will have next month on the 9th and 10th of May, we will have the FAMIVE recent development and experience. This is a procedures that indeed we have used in the Philippines in studying the heritage building of the Philippines in our previous projects, and we have very recently created a new interface and changed the program so that it's more user-friendly to the end users, and we will expand on this and on various applications that are led from the data collection and analysis of the failure mechanism of masonry structures to the definition of their fragility and risk and possible mitigation measures, again, to increase resilience. So this is next month, and we look forward to seeing many of you in that occasions. Now, very briefly, before I pass the microphone to Professor Ureta, I will just like to very quickly outline our collaboration between UCL and the Philippines Institution of Resilience. So we have worked extensively with a number of institutions, but very importantly with De La Salle University and Xavier University in the now for more than 10 years. And we particularly deliver through projects, the SCOSO project and the PRISM H project between 2016 and 2020. We delivered a very comprehensive approach to the multi-hazards of schools in the Philippines, delivering both app for rapid assessment and rapid screening of building, to a full-fledged approach to determine flood risk and seismic risk, and therefore measures of recovery. And we also did extensive CPD and capacity building with a number of workshops and conversations and discussions. Similarly, we have worked extensively also following the Bohol earthquake of 2013. We looked at the heritage of Bohol at Cebu under multi-hazard assessment, and we determined a procedure by which data could be collected on both damaged and undamaged buildings and define their level of risk and therefore the most appropriate mitigation approach. Without further ado, at this point, I would like to pass the helm to Professor Andy Ureta, but please do not forget towards the end to look at this, to catch the you are here and provide us with your assessment of the webinar. Thank you very much. And with this, I think I can stop my sharing, and please, Andy, if you want to share your video.
Okay, good afternoon to in the Philippines and good morning in the UK and the Europe. So first of all, can I ask you if you can hear me clearly? Hello, can you hear me clearly?
Yes, we can all hear you.
Yes, yes.
Okay. So let me start my presentation, Capacity Building on Disaster Mitigation Preparedness and Response, an overview of the ASEP DMPR Training Program. So I'm Andres Winson C. Oreta, fellow of ASEP and professor of De La Salle University. So as you all know, the Philippines is one of the most hazard-prone and disaster-hit countries in the world. As you can see, we have here a menu of various types of hazards and that resulted to disasters from earthquakes to storm surge. In one of the studies of a UK-based research group, it says that the Philippines is #1 disaster-prone country and #9 earthquake-prone country worldwide. So because of this, it is very important that you can see earthquakes are more frequent and damaging. As from based on Phoebus, we experience about 5 earthquakes per day. No? And you can see here images of various most recent earthquakes that have affected the Philippines in Surigao, Davao del Sur, Abra, the latest Abra. And with the expected big one in Metro Manila, obviously we have to prepare for earthquakes, no, and build resilience specifically in structures. Not only earthquakes, the Philippines has been regularly visited by typhoons and has affected various areas in the country. For example, no, Mindanao, which usually was was a typhoon-free region in the Philippines, but now it has been being visited by various strong typhoons and affected that region from flood, including strong winds. So basically, because of that, the structural and civil engineers have an important role in advancing infrastructure resilience, and the Association of Structural Engineers of the Philippines have been advancing various activities, seminars, conferences to promote infrastructure resilience, and the Disaster Mitigation Preparedness Response Training Program is one of them. DMPR, sometimes we pronounce read it as damper, no? Because as you all know, a damper is a device used to prevent discomfort, damage, or structural failure due to vibrations. So basically, the objective of damper is similar to of DMPR is the same as damper. No? So basically, let me give you an overview now of DMPR training. The objective of DMPR is basically to provide reserve inspectors of structures and facilities in the event of an earthquake specifically and other hazards. The DMPR training actually aims to build the capacity and know-how of volunteers on the 3 major performance outcomes. No? First is rational understanding of DRRM concepts and hazard assessment, tools, application of pre and post-earthquake disaster forms and tools, and number 3, methodology, inspection and assessment of the damage to various types of structures like RC, steel, and masonry. No? So these 3 outcomes are designed into ASEP DMPR modules, which I will now describe to you very briefly. So the first set of modules, the modules hazards and DRM concepts consists of the following subtopics. No? And let me show you the first subtopic, module on DRR terms and infrastructure resilience. Basically informs or orients the volunteers on basic definitions or terms which have been defined by UNDR. It is very important for civil and structural engineers to have common understanding with these terms with respect to DRR experts or advocates. No? Specifically, the framework of the relationship between hazard, vulnerability, resilience with disaster risk is very important for us, no, to implement infrastructure resilience. A module on understanding or about the National Disaster Coordinating Council, Philippine DRM Act of 2010, and Sendai Framework is also included as one of the topics in the modules. Of course, a module in on hazard in the Philippines. Specifically, we focus on earthquake and wind. Okay, in these modules, the focus is on the code provisions on seismic and wind design, earthquake hazards, and wind hazards. There's another module on geotechnical hazards, specifically the highlights of which are effects on soil type to ground shaking, geotechnical hazards, liquefaction, and landslide assessment. And these are sample slides. No? The second set of module consists of modules on the application of pre and post-earthquake disaster assessment forms. Specifically, uh, starts with a pre-earthquake evaluation of existing buildings, wherein we present the FEMA P154 rapid visual screening of buildings for potential seismic hazards. The second subtopic is the post-earthquake rapid evaluation procedure, wherein we orient the volunteer inspectors on how to inspect damaged structures and how to recommend, what to recommend as an assessment poster, whether a green, which means inspected, yellow means restricted use, or red, meaning that the building is off limits because of the damage condition. A related module is a post-earthquake, but this time detailed evaluation procedure wherein a more detailed checklist is used by the inspectors, no? Including, in some cases, non-destructive testing. But the main objective still is to be able to recommend to the building official of the LGU on whether the status of the building is a green, yellow, or red. The third set of modules is on inspection of damage to structures for different types of materials. No? The first set consists of inspection of concrete buildings, wherein the key inspection points, specifically the vulnerable points of concrete structures, are highlighted. No? We try to focus on specific weaknesses of concrete structures like a soft story, a strong column, weak beam principle, beam column joint failures, and others. And based on the inspection, again, the recommendation of green, yellow, or red posting will be recommended. And you can see here examples of photos of damaged RC structures in past earthquakes in the Philippines. Another module is inspection of masonry buildings, wherein we discuss an overview of masonry structures, CHP masonry houses in the Philippines, and common types of masonry failures and examples of failures of CHP structures as shown here. Another topic is a module on inspection of steel structures, wherein the participants were familiarized with various types of steel structures, from warehouses to buildings, and the common types of framing systems used, and of course, sample of damaged structures from simple failures to total collapse of steel structures. Finally, the modules on inspection of lifeline structures includes inspection of bridges, inspection of flyovers, and pipelines. Again, the key points of the type of failures of these various types of lifeline structures are also presented. The DMPR training actually consists of it's usually conducted for 2 days, and what the modules which I discussed earlier are discussed in this 2-day training. And here is you can see on the right side a sample program of the DMPR training, no? Starting with the module 1 up to the final activity, which is a post-test. And you can see here the photos of one DMPR training in a specific location in the Philippines. One of the activities after the lectures in the DMPR training is a rapid evaluation exercise. No? Specifically, the participants assess the damage shown in photos using RBS. No? So instead of conducting an on-site inspection, of course, which cannot be done in a 2-day training program, what we did is basically more of a exercise on during the conference, during the training. So the team are presented a set of photos of a specific building, and they assess, like this one, they assess whether this type of will be a green, yellow, or a stick. And at the end of their exercise, each team, no, the participants are grouped into a team. Each team presents a final report, no, and of course the ASEP experts will comment on whether they did well or not. The final activity in this DMPR training is what we call the post-training assessment, or it's like a quiz or examination, wherein the participants take an exam, a quiz. No? It's usually a multiple choice exam. And based on the scores, they may qualify as either a structural safety evaluator if they meet the criteria, or a responder. No? First, for you to become a structural safety evaluator, you need a score of 70% and 60% for a responder.
Doc Andy, 2 minutes, please.
Another
Thank you.
criteria is for a responder. Okay, another criteria is that for a responder must can be can be an architect or engineer. No? But for a structural safety evaluator, he must be a regular ASEP member, and of course must get a 70% rating. So that's the difference between a responder and an SSE. And one of the obligations of the SSE is he or she may become a team leader during an actual inspection. So this is an example. These are the some DMPR things conducted in the Philippines so far with SC responders. In the DMPR thing will be next starting on April 26, 2024 in Tuguegarao City, Cagayan. And this is just an example of an actual earthquake wherein the volunteers, no? Hello, guys. Okay, still on.
I think we lost Doc Andy. Doc Andy, are you? Oh, maybe we can proceed and go back. Okay, I think he's back. Doc Andy, are you back? See, please wrap up po. Thank you. You are muted, Doc.
Where was I cut off? In what particular part, Dexter?
Yes,
Yeah,
this
that one.
slide. Yes.
This slide. Okay, this slide. Okay. Anyway, this slide this basically presents the uh, uh, actual inspection, July 27, 22 earthquake. No? Okay, I would just like to share a simple video. This is just the technically, I don't know if you're familiar with this dance, but basically this technically dance, it is a dance of resilience. So because when the bamboos are very near, the risk is very high. And the bamboos were very far, the risk may be very low, but the technically dancers, they continue to dance, whether the risk is high or low. And that is basically a symbol of resilience. No?
Thank you very much.
Okay, thank you. Thank you very much. That's all for my presentation.
Thank you, Doc Andy. For those who have questions, we welcome them on the chat box, no, and our speakers, and we will try to answer them immediately. Let us now proceed to Doc Gigi Garciano. Please. Thank you, Doc Andy.
Hi, good afternoon, everyone. So let me share my screen. Here's the title of my presentation, Lessons on Damaged Structures from Past Earthquakes in the Philippines. So this is an ASEP post-earthquake assessment. And basically in this presentation, I'll show you lots of pictures within this 15-minute time frame. So basically, I will talk about a bit of the background. Dr. Andy already talked about damper. Just briefly talk about the ASEP study team, which normally goes in parallel with the damper team. And our deployments to various earthquake hit areas since the 2013 Bohol earthquake, and some observations and the lessons we have learned from these deployments. So as a background, Andy mentioned already the damper group, the Disaster Mitigation Preparedness and Response group, and you can see there how it is being, how we, the system of the organizational chart for damper. And I am part of the training and research group together with Dr. Andy and Dr. Mendoza also here. On the other hand, if damper is mobilized when there's an earthquake, we also mobilize another team, which we call as the ASEP study team. And you can see here the members of the ASEP study team. And we are more flexible because for damper team, they have to go with the LGU, and especially for the postings of the green, yellow, and the red cards. But for the ASEP study team, we can be flexible, and we can divide into groups and choose which areas we want to study specifically for, if you want to include this lessons learned in our code. So these were the deployments of the ASEP study team before, and actually they're hand in hand with the damper team. So we started. Well, I started in the ASEP study team in 2013 during the Bohol earthquake and succeeding deployments. And the last one that I took part in was the 2023 General Santos earthquake in Jensen, the southern part of the country. And in 2013, we had the Bohol earthquake, and this you can see here the study team. It was a 7.2 magnitude earthquake, and we were able to see the damage of various infrastructure, like hospitals. Not only structural damage, but as well as non-structural damage, especially to the hospitals with equipment. So I will not go into detail because so I can finish the presentation in the time allotted. And we have also damage to houses. and to different various reasons why these houses failed, like soft story structure, detailing problem, connection problems, and so on. Later on in the summary and lessons learned, I will try to summarize what have we learned from these damages that we have observed during this several earthquakes since 2013. So damage to houses, we have damage to bridges, the Abatan Bridge, which made everyone inconvenience everyone, because instead of going through the other island in several minutes, you have to go around for 2 hours to go to the next town because of the Abatan Bridge failure. And you can see the superstructure that failed during this strong earthquake. And of course, other bridges that were also maybe from moderate to extensive damage. Tagbuana Bridge, Moalong Bridge, the Samparados Bridge, Mandaog Bridge, and so on. Even a steel bridge in Clarin is also damaged in the earthquake. And damage to public buildings like municipal halls, public markets, city halls, and so on. So really, the 7.2 magnitude earthquake in Bohol in 2013 damaged a lot of structures from the public, private, as well as heritage historical structures. And Professor Dina de Ayala knows this very well, because we were doing research on the historical structures in after the Bohol earthquake. So a lot of these churches in Bohol were damaged, from moderate, minor, to even to total collapse of two churches in Bohol. And then usually after this visit of the ASEP study team, we try to put it in a paper, and we submit it to the Journal of Disaster Fact Sheets of the JSCE, the Japan Society of Civil Engineers. And you can see this write up in online of the JSCE Journal of Disaster Fact Sheets. Yeah, and then in 2017 we had the 6.7 Surigao earthquake, but it was not so. The damage was not so was not as much as Bohol earthquake. But we saw this damage in one of the schools and one of the mall in Surigao, including, and most importantly, the water distribution network. And then we began to think about how we can estimate some kind of resilience index for water distribution networks, because they are also, buried pipelines are also vulnerable to extreme ground shaking. And you can see there here in the screen the drop of the water supply when the earthquake hit Surigao. But they were able to recover it in, I think, in about 3 days, recover as much the water supply than before the earthquake. And we also submitted this findings to the GSC Journal of Disaster Fact Sheets. And then in 2019 we had we call it the Porac Pampanga earthquake, which was the magnitude was 6.1, and one important observation here was the damage to a supermarket, the Chuson supermarket, the top left photo. And I think there were fatalities in this during when it's collapsed. And the other damage were seen in churches like the Santa Catalina Parish Church and Pio Church, and some other churches with minor damage. And again, we wrote a paper and submitted it to the JC Journal of Disaster Factions. And in 2019, we had a series of earthquakes in the southern part of the Philippines. We call it the 2019 Cotabato earthquakes. A series of earthquakes in a span of a week, and it caused a lot of damage because of this 6.6, 6.1, and 6.5, which are moderately high magnitude. And those structures that were initially damaged collapsed after the next series of earthquakes that occurred after the first the main shock. And this is a photo of the Eva Hotel that was completely damaged after the earthquake. And you can see here a snapshot of some members of the ASEP study team that also visited this Eva Hotel that actually was demolished later on because it had an extensive damage during the earthquake. And again, we also took note of the water distribution network that was affected during this earthquake. And you see on the top left of your screen, water were transported by motorcycles and trucks because water just stopped because of the leaks and the damage to the distribution network, as well as damage to schools. Condominium was completely damaged. Bottom right of your screen, damage to cover courts. A bank also was structure was damaged, and so these experiences starting from 2013, you can see various damage and the vulnerability of structures, especially to strong magnitude earthquakes. This was the water distribution network that was damaged, and I think it took them several months because of the landslide in the, especially in the higher portions of the area. It took them a while to be able to restore completely the water distribution network, especially for areas in the mountainside. In 2022, we had the northwestern Luzon earthquake, and it's where Vigan is. If you're familiar with Vigan, the site of the World Heritage Site, and the magnitude was 7.0, and the bell tower at the back of this photo was also damaged. And I think that will be the topic of Dr. Mendoza later on. This is a photo of the study team, and we were allowed to go into this near the structure to be able to see take notes of what how this historical structure performed during the earthquake. And here you can see the damage to the church, the cathedral, St. Paul Cathedral, the one of the old heritage house within the World Heritage site of Vigan. Again, the Bantay Bell Tower. We also saw lateral spreading as well as sun boils during the earthquake. And two bridges that we visited exhibited minor to moderate damage. And you can see
Doc
that
Gigi, 2 minutes, please. Thank you.
And we submitted this, but hopefully we'll receive feedback from GSE. And the last one that I joined with the ASEP study team was the 2023 Jensen earthquake, moderately 6.3. But what was, I think, important here was that one of the pier of in the area sank, and but otherwise there were moderate damage to structures. So if to summarize everything what we have learned, we know that heritage structures are very vulnerable to strong seismic action, and we have seen elements that fell during the earthquake, unsupported vertical elements, keystone that were displaced and resulted in bolt damage. Non-maintenance of heritage structures increase vulnerability and damage. Water distribution networks, old pipes are susceptible to damage. initially we don't know where the pipes are, the operator, and therefore they will only know that there's a pipe crossing in that area if there's a leak. And other attendant hazards like liquefaction can also result in water loss. And I think this is second to the last slide. A lot of residential houses were damaged because of poor workmanship, detailing, the hollow blocks that were used were of low quality. We have seen the absence or the lack of reinforcements. Wood frame houses were also damaged. A lot of non-structural damage, partitions, claddings also fail and can pose as hazard to people. And finally, I think very important is we enforce the code in compliance to our code, which is the National Structural Code of the Philippines. And hopefully this can protect us, especially during strong seismic action. And as you have seen in the previous picture, some of the equipment in hospitals were damaged because the connections were not detailed properly. And so with that, I end my presentation. Thank you very much.
Thank you. Thank you very much, Doc Gigi. Let us now proceed to Sir Johnny. Of course, you have questions for Doc Gigi, kindly place them in the chat box. Sir Johnny, thank you.
Good morning, good afternoon, good evening to everyone. Okay, let me start with my presentation. And this is about the Philippine government efforts to make public buildings resilient. Okay, so the outline of my presentation will consist of the following. A review of the seismic scenario in Metro Manila, and followed by the efforts of the government in making police resilient. So as a review, this series of actions started when the Philippine government, through the Metropolitan Manila Development Authority or MMDA, the PHIVOLCS, the Philippine Institute of Volcanology and Seismology, and JICA, Japan International Cooperation Agency, released this study titled Metro Manila Earthquake Impact Reduction Study, or very commonly termed as MMIRS. These MMIRS presented the possible earthquake scenario that would affect the metropolis. And of course, this is due to the seismicity of the Philippines, as mentioned by Dr. Andy and Dr. Gigi a while ago. And Metro Manila, with over 10 million population right now, has this profile. And considering that it is the center of the political and economical backbone of the country, it has to be addressed. And as you can see, seismic hazard evaluation that can be caused by these hazards, which is surrounding the metropolis. We have two major trenches in the east and west, and within the mainland, there are known fault lines. And particularly in Metro Manila, there is this valley fault system that could cause a severe earthquake. And historical earthquakes, from the recollection of historians, these are the recorded earthquakes surrounding the Metro Manila, with estimated number of casualties. And of course, when the instruments began to be used in the Philippines, these are the instrumentally observed earthquakes within the region that could affect the metropolis. And the study highlighted 18 possible earthquake scenarios. And 3 of these were considered to be critical. The Model 8, 13, and 18 that has the magnitude of 7.2 from the West Valley fault line that is within the Metro Manila. And it could have severe damage, while the Model 13 from the Manila Trench could cause tsunami, and it is expected that the magnitude 7.9 could be generated, while the Model 18, 6.5 magnitude on the Philippine fault that could also produce strong ground motion or ground shaking. And these are the study, no, that were created under the MMRs. The peak ground acceleration, as you can see, there is a maximum of 1 to 1.6 G that could be experienced within this highly colored in the map for the Model 18 or the West Valley Fault generator. While this, the intensity, Fibonacci intensity scale could reach up to a maximum of intensity 9 on the red colored part of the metropolitan region. And also, it was noted that there is a liquefaction potential with those in intense color are prone to liquefaction in either one of those three models that were identified to be critical. And in 2004, this is the statistics of possible building damage. And for the total number of more than 1 million buildings, 26% are partly damaged, while 13.2 will have heavy damage. And this is a combination of both liquefaction and vibration hazard. And for the residential, we can see that a lot of residential buildings will be prone to damage or collapse. And this is because most of the residential houses within Metro Manila are either non-engineered majority or most of the buildings that will be affected will be coming from the residential buildings. Could be damaged, and numbered as 177 buildings, schools 1,412, etc. And this will possibly sustain heavy or collapse. There is also a scenario of lifeline damage for water pipelines, electric cables, phone cables, and there were 7 high possibility of collapse breaches identified in the study. And there are expected fire outbreaks as well. And the overall scenario summarized in this slide. Building collapse, fire, and evacuation difficulty will pose a great problem. So what is the government response? And this is the part 2 of the presentation. Since then, the national and local government conducted infrastructure audit nationwide. So it is a combination of effort of the national government, the national agencies, and the local government. And as mentioned in the earlier slides, there were bridges and structures that are prone to damage and collapse. And these were the initial retrofitted structure. And as part of the response, the local government and the national government enacted ordinances. The national government through the DPWH issued circulars for mandatory inspection of all buildings with high occupancy. And it also evolved into the enactment of the Philippine Disaster Risk Reduction and Management Act of 2010, which is the RA 10121. And also the approval of the revisions of the National Structural Code prepared by the ASEP, the NSCP 2010 edition and the 2015 edition. The passage of the DRRM law in 2010 enhanced the following initiatives by making the DOST the vice chair for prevention and mitigation. A lot of studies about hazards took place, and it is the reason why the earthquake maps were produced by the PHIVOX. The Pagasa provided a lot of information and data about severe winds that are both the most virulent when it comes to hazards. Preparedness was undertaken by the Department of Interior local government through the local government units, and they focused on infrastructure audit towards resilience. And of course, response and rehabilitation for those that will be encountered is taken care by separate agencies, the DSWD and the NEDA. So the DPWH in particular issued memorandum circular for building officials to conduct annual inspection of private buildings and design of infrastructure based on the updated design guidelines, criteria, and standards. They also initiated the conduct of rapid visual screening of all public buildings in Metro Manila for seismic vulnerability and detailed evaluation of those identified to be seismically vulnerable structures. And the last part was subjecting those identified as seismically vulnerable to detailed engineering evaluation, which is referred to in the projects as the Big One projects. And these structures were evaluated towards retrofitting. This is the one of the issuance provided by the DPWH in 2007, wherein it requires all building officials to conduct annual inspection of buildings within their jurisdiction. Actually, this is not just for the Metro Manila, but it is a nationwide circular ordering the local government units nationwide to do the annual inspection of all buildings due to earthquake hazards. And this one is the design guidelines, criteria, and standards set by the DPWH as the new criteria in designing structures. And its goal is to lead to an efficient, economical, and improved quality of design of public infrastructure for safer and more efficient public infrastructure for the people. Okay, I would just like to emphasize what the Big One project is. I was, in a way, part of this project as a consultant towards retrofitting, and I have a very familiar idea about this project. So this project focused primarily on the vital structures within the critical ranges from the valley fault system and old or seismically vulnerable structure. And the target performance for buildings is to include post-emergency accessibility and usage, because in the Philippines, there are not much facilities for post-disaster. So the existing buildings should also serve the purpose of evacuation centers and the like after or during emergencies. Phase 1 was launched in 2017, Phase 2 in 2018, Phase 3 in 2020, Phase 4 in 2021. So looking at this map, the semi-vertical line is the valley fault system, and this is Metro Manila, this within the highlighted portion. And there are more than or there are a lot. No? I forget the exact figure of public buildings, but there were identified 1,400 school buildings to be damaged in the Model 8 or the West Valley Fault action. And these are
2
the
minutes po,
actual
Sir Channing.
package.
Thank you.
Yes, yeah. Okay. These are the actual projects sent out for consultancy. And phase 1 composed of 145 buildings, both hospitals and school buildings. These are those that are very near the fault line, within 5 kilometers from the fault line. And phase 2 was expanded to the rest in the southern part of Metro Manila, composed of 334 buildings. In 2020, there were 468, including now within the 10-kilometer radius from the Valley Fault system. And in 2021, there were 128 additional buildings subjected for detailed engineering evaluation. And these are mostly, or all of them are school buildings. So all of these phases 1 to 4 were concluded with total number of 1,075. Buildings were all subjected to retrofitting, and there is a various degree of retrofitting required in each. And some were recommended for condemnation and demolition as they have excessive failure and excessive retrofitting costs beyond repair. In 2023, Phase 5 was conceptualized to cover buildings outside Metro Manila, but has not been implemented as of this time. And now, those that were in the Phase 1 and Phase 2 were already out for bidding and implementation. But later, new updated terms of reference was formulated to introduce multidisciplinary planning other than structural retrofit, such as accessibility, gender sensitivity, environmental compliance, and other non-structural aspects necessary during the retrofitting process. So the modified implementation for execution of retrofit and amended POR is now on bidding process. This is the list, and there are about 400 plus buildings subjected for execution. This particular project is for project main management and additional study for the expanded TOR. And these are the buildings that is covered by the project under bidding. So it's now out for bidding and soon will be implemented. So as a conclusion, the government through the national agencies and local government units are doing their part in the prevention, mitigation, and preparedness strategies. And actions and trainings for response and rehabilitation plans are also in the pipeline. Also, communities and civil society organizations are contributing in all efforts to realize the resilient Philippines. Thank you very much. And that's the end of my presentation.
Thank you very much, Sir Johnny. Thank you. Again, if you have questions, please key them in the Q&A box. We will try to address them immediately. Thank you. We will now proceed in the interest of time. No, we will proceed immediately to the next presentation. May I call on Asana, please?
Hi, everyone. Thank you, Dexter. Please let me know if you can see and hear me well. Yeah.
Yes, we can.
We
Yeah.
can.
Hi, everyone.
But
Thank
no
you. Sorry?
Presentation? No presentation yet.
No?
You're not sharing your screen.
Sorry.
We are seeing the wrong, yeah.
Now it's fine, I hope.
Perfect.
Yeah, okay. Hi, everyone. Welcome to this webinar. It's very interesting, and it's really interesting to see how the government is already taking so much of initiatives to improve the resilience in the country. In this particular presentation, I'm going to talk about two sets of data collection surveys we carried out with Xavier University in the country, in Cagayan de Oro, focusing on schools and road transport infrastructure. This is part of this ongoing project with UCL and XU on minimizing disruption of education following natural hazards. What we are trying to do through this project is to bring together different elements of education delivery and consider this as a system that performs together in the aftermath of a hazard. As we have already seen from previous presentations, the hazard levels of the country from various hazards, including earthquakes, hurricanes, and floods, is quite significant and severe. What we are trying to do in this work is to consider the service of education delivery through schools by considering the vulnerability of school infrastructure to these hazards such as earthquakes and floods, and then how the mobility and accessibility aspects that come from the road network contributes to the faster or slower recovery of education services. So there's also this element of the community that is using these facilities, and the use of schools as shelters and other layers of more information that goes into such a model. In this part, one of the main inputs definitely is the information on the existing infrastructure. So the survey of schools, as we have done also in past projects, as Dina mentioned in the introduction, such as PRISM H and SCOSO, where we focused very much on schools and their multi-hazard vulnerabilities. In this project, we are looking also on the connectivity aspect, as I mentioned. So with Xavier University, Dr. Dexter's team, they have carried out a massive collection of data on 7 schools, as you can see here, which are in Cagayan de Oro City. We will go into details of the survey as we go on in this presentation. What we would then do using this information is to carry out this project. The general framework is shown here, where we would assess the current levels of seismic and flood hazards, along with the current condition of the infrastructure, which comes from the survey results. With that, we can then have a resilience model, a statistical model tools such as Bayesian networks and agent-based model, where we assess the school resilience of current services. So with that, we can then have different analysis carried out, such as if you were to do some interventions, how cost effective they are, how much of reduction in the overall disruption is achievable, and how to what level of better performance you can bring these infrastructure elements to. So in this, we are first going to focus the first step of the task, which is the data collection, as I mentioned. So the stage 1 data collection was carried out as a hybrid workshop for stakeholders in the country. So this included administrators and managers from several government offices, such as the education, transportation, disaster management, and also the school principals and managers who are the first-hand responders and who have the experience of past events occurring in their vicinity. So this was carried out in person for the participants from Philippines by Dexter and team, and we from the UCL were contributing online and through the questionnaires. So we first provided some questionnaire-based assessment for their general preparedness, and also specifically for seismic and flood hazard situations. So the purpose was to understand the likelihood of all these possible options that are possible for each of these questions. So each of these questions then can be an input factor in our resilience model. So second stage of the data collection, which is the glossy and Parnassus approach, this was carried out in person, again by a team from Xavier University. And this was specifically done for seismic and flood vulnerability through questionnaires. And we have our lovely team here who have done a fantastic job getting all of this information. And as you can see, this is very extensive in terms of we look at the overall outside and inside and detailed dimensions and surroundings of these buildings, and also the transportation infrastructure that is connecting all of these schools under the study. So the first one I will talk about is the Parnassus approach for flood vulnerability. This has been developed the past several years now, for initially for heritage structures and then extended to other types of structures as well. The purpose is to characterize a building and its flood vulnerability through a set of parameters, such as the ones listed here you can see, and have the attributes of these parameters in a range that is from the minimum to maximum possible in the region. So for each of these attributes, we can then assign a vulnerability rating, which is based on expert judgment and experience. And such a form is provided to our survey team, where they would go to the field, assess the immediate building and its surroundings, including things like drainage system, any presence of prevention of flood features, or the type of building fabric and the building condition, which basically involves how good or how bad or how it is maintained and how it's built. So we can then have a summation of all of these vulnerability ratings to get what is the vulnerability index of each of the buildings in the sample. So we get, for this case particularly, we see a variation between about 400 to 850 in value for the vulnerability rating. Just to get a common ground for comparison, we normalize this value to get normalized vulnerability indices. And then we can fit a log normal distribution to get a usable function as a vulnerability indicator of this sample. So with this, we can then combine the knowledge of hazards in the region. As you can see, we see several of the schools under our study being in low to medium hazard with respect to flood, and then we can continue to calculate or estimate the economic losses. So for example, if we are considering a uniform flood inundation depth, irrespective of the topology of the land for the time being, we can calculate the economic losses as a function of the replacement cost of the building per area, the damage factor, like how much of damage is expected for a given flood depth at the building location, what would be the vulnerability factor, which is a function of the index we calculated previously, and then the footprint area of the building. So this factor, as I mentioned, the depth of water, actual depth of water at building location can still be different for a uniform flood inundation depth, because we see that there is a variation of the height of base or the level of base of the building from the surrounding environment of the building, such as the road surface. So if the building is already at an elevated level, you get a lower flood depth at the building location, for example. So then with each of these actual flood water depth, you can calculate what is the expected damage percentage. This is a compilation and regression of data from literature. I am providing the references if anybody is interested in getting a detailed reading of this. With that, we can have the economic loss calculated, considering some assumptions for calculating the cost of the building, which accounts for the actual construction cost, and a value factor, which indicates the age and the condition of the building. The poorer the building, you have lesser value starting from the construction cost. Similarly, the cost of contents, this is the perishable or damageable content the building has, and this is a percentage of the cost of the building as we calculate here. So for the 7 buildings, we calculate these for the assumed 1 meter flood depth, for different actual water heights of the building, as I mentioned, how the estimated replacement cost varies, as you can see on the right, and the total amounts about 5 million in US dollars, as you see here. So this is, as I mentioned, it's based on these particular assumptions, and these are customizable and modifiable for the information we have. Now, how we utilize this is to find specific trends in these variables, like some certain parameters are going consistently poor or good, and also to identify most vulnerable ones, or like how do we do quantitative study of the influence of other certain interventions. So just as an example, a hypothetical example of if you have this is the current condition of the buildings in the sample, the 113 around buildings. And if you assume to bring them all to excellent condition, this is again a bit subjective in the sense that you need to look at the exterior, interior, and the surrounding of the building, its make, its age, its current maintenance status, and the quality of the overall quality. It will give you at least about 45% less losses in total. So the whole overall purpose is to then how we can have these interventions so that we improve resilience and minimize the disruption to education infrastructure as a whole. So this is with respect to the flood vulnerability. If we quickly go on to the seismic vulnerability assessment using the GLOSY taxonomy, this is a World Bank initiative project run a few years ago by UCL and UNIANDES to actually develop a system of classifying buildings through, again, a set of parameters. But instead of the vulnerability ratings, we give them a taxonomy string, a code for each of the parameter that then together forms the DNA of the building. So we have a specific course on this, we run already done by UNESCO Chair. If anybody is interested, it's available to view free online. So these are the 12 parameters we consider in GLOSY, all of them as an indicator of the seismic performance of the structure. As you can see in more detail here, there are about 3 primary parameters and other secondary parameters, and how each of them contributes to their seismic performance. For example, the seismic design level, which is often considered to with respect to the age of the structure and the seismic codes that the building is conforming to, or the structural irregularity, whether it's regular or irregular, horizontally and vertically, and so on. And there are also different typologies accommodated in this taxonomy, such as the RC, reinforced concrete, or load-bearing masonry structures. And for certain parameters, we see that these conditions of different parameters can be different depending on their load-bearing elements. So
2 minutes, Atana.
Okay.
Thank you.
Thank you, Dexter. So all of these parameters, as I mentioned, can have these different attributes, which, so for each of the buildings, we can then identify what is the specific attribute. Does it have a short panel or a long panel, as opposed to, say, small opening, large opening, and so on. So giving these strings then lets us identify, for example, distribution of all the typologies and the recurring typologies in the sample. So it's really interesting to see that even the minor variations between 2 different buildings are well captured by this typology. And we can have a more coarse classification looking only at the primary parameters for our analysis purposes. The aim is then to identify these kind of most recurring typologies, which can be then characterized and classified to resemble existing typologies and whose fragility functions are known or already developed either in the country or elsewhere. So these fragility functions directly give us the damageability or the probability of damage to these buildings for different hazard intensity levels. So this is the main input that would go into our model. So the last element is the road network. As I mentioned before, we covered about 8 bridges, 2 flyovers, and 6 overpasses in great detail, thanks to the team from Xavier University. And we are also now assessing the data to see and assign typologies to these structures so that we can identify suitable fragility functions for them. And at UCL, we are also developing this detailed road networks and maps around each school to assess the local connectivity of the community with the school and also the regional connectivity between the schools. So as I mentioned, this will then feed into the overall framework, into the data model, the Bayesian network, and agent-based model for recovery analysis, which we are considering as our next step. And I think that's due to considering the time, I will stop my presentation here. And these are some of the publications if you would like to go through more details. And the last 2 links give you more access to available courses and resources regarding GLOSY. Thank you very much. And I look forward to hearing 2 other presentations. Thank you.
Thank you very much, Asana. Thank you. May I now call on Doc Mac Mendoza?
Can I share my screen, Dex? Thank you.
Yes.
I cannot
So
share my
Asana
screen.
will. Yeah.
Okay.
Can you please? Yeah. Okay. There.
Okay.
Okay. Thank you.
Okay. Good afternoon here in the Philippines and good morning in Europe. So I will be presenting the case of the St. Augustine Parish Church in Ilocos, which is more commonly known as the Bantay Church. And here I'm going to present the structural evaluation and damage assessment we did, as well as the simple intervention that we actually implement for this project. This is the content of my presentation. So our team was engaged to actually do a damage assessment as well as structural evaluation of the St. Augustine Church, or more commonly known as the Bantay Church in Ilocos Sur. Now, this damage assessment was requested because of the damage incurred to the structure after the July 27, 2022 Luzon earthquake. The test that was performed by our team is first to do a damage assessment, and because of the lack of plans and available information of this existing church, we were also tasked to do an as-found drawing development, or what we call as-found survey, as well as material characterization. The material characterization we did is basically to conduct a test on the chemical analysis of the composition of brick and mortar. And then again, due to lack of information, we needed to do a wood identification in order to identify the species of wood that was used for the timber structures, as well as for the roof structures. And then we also conducted flat check tests in order to determine the mechanical properties of masonry. Then a structural analysis was conducted, and here we utilized nonlinear analysis in order to determine the capacity of the structure, while the demand displacement were determined using a linear analysis. And from this, we were able to derive some conclusions and some interventions for the structure. So the building is a typical Spanish era church building in the Ilocos area, wherein the entire structure consists of majority masonry walls, and the masonry walls are a combination of clay tiles, brick, as well as lime mortar. The roof system is completely timber structure, as you can see here. And the plan showing you here a typical nave part of the structure and a transept on this part of the structure. And the masonry system consists of around 0.2 meters thick of brick and lime mortar composition, while the interior of this masonry wall consists of loose stones and debris, which are somehow loose to partially loose. The exterior walls of the structure is actually around 2 meters thick, and almost around 1.6 meter of that 2 meter thick wall consists of these rubble stones, which are then infilled by this exterior assembly of clay brick and lime mortar. The ceiling the roof system consists of this very unique arch system, which purely timber. And this timber then is supported by timber posts, while the sides were supported by these masonry walls. In the damage survey that we conducted, we found out that majority of the damage of the structure were somehow not just attributed to the movement of the walls, but also attributed to the infiltration of biological growth to the masonry. And you can see right here in the screen are the roots of this vegetation that actually infiltrated into the interior part of the masonry. And that interior part, or the exterior face of that masonry, which consists of the masonry brick and lime mortar, just fell off and totally collapsed. And that is also the case for the entire faces of the church, wherein you can see here a clear vegetation surrounding the entire area. And we were able to confirm that this vegetation, the roots of this vegetation extend inside the interior part of the masonry wall. Now, we did some material characterization by taking samples of bricks as well as lime mortar and did mechanical testing on this composition. We also did chemical analysis in order to determine the chemical composition of both brick and mortar. And for the timber elements, particularly for the roof truss system, we also did a wood identification in which we found out that the roof system of the Bantay Church consists of very different species of timber from Malabe, Ipil, Yakal, Tangile, and even some species that are not actually locally available in Ilocos. And from the wood identification, we were able to determine the mechanical properties of timber that we use for our assessment. For the masonry wall, we conducted flat jack tests in order to determine the properties of the masonry walls. And here, this is just showing you how we conducted the flat jack testing by actually monitoring the displacement as we apply the load. And of course, there are normally 4 points across one test, and we develop what we call the force displacement curve relationship for a wall. At least 4 flat jack tests were conducted for this church. And this is the actual setup for the flat jack test conducted. And these are the test results for our flat jack test. It just so happened that we found out that there are some instances that when we apply the flat jack test in some of the walls, there's a rebound that we experience in the wall. So we need to increase the rate of load application in order to prevent the rebound from happening. And from there, we were able to determine the elastic modulus of the masonry from our flat jack tests. In order to confirm the results of the flat jack test, our team also conducted a masonry quality index in order to confirm the results that we got from the flat jack test. And the MQI basically is just a visual way of determining the masonry properties to what they call rule of art. This was actually introduced by one of our engineers here at Patrick Jacob. And this is the resulting MQI index properties of masonry walls, which somehow correlates very well with our test results from flat jack. From the material properties, we then adopted these properties in order to determine the Poisson's ratio, compressive strength, as well as tensile strength of the masonry properties. And from here, we were able to develop a masonry stress strain curve that this nonlinear material property was then used to model our masonry using nonlinear analysis. Now, in order to confirm that this masonry properties is actually adequate for our assessment, we conducted some model validation, and we utilized some experiments did by NCRE for masonry wall system. And from there, we utilized SAP 2000 in order to validate our input. And the yellow curve here is the one we adopted for our analysis. And from that, we input those nonlinear models that we use in our SAP 2000, and we were able to develop this analysis model for our structure. And from here, we apply the loads, and from these loads, we perform initially what we call a gravity analysis for dead loads and live loads, just for us to benchmark our result in terms of gravity assessment. The gravity assessment provided a consistent behavior in terms of the stress analysis from our SAP 2000 model. And we were also able to confirm the stress concentration as observed in the actual condition of the structure. Now, the nonlinear analysis was conducted in order to determine the capacity of the wall. So we have two nonlinear analysis. Here, The pushover analysis was used in order to determine the capacity of the walls in both directions. And we actually implemented the Italian code in order to check the acceptable limit in terms of the damage control drip. And what you can see here is the idealized SDO web curve for our walls in the longitudinal direction. The red plot here showing you the damage control drip at 0.2%, while the black line here showing you the demand drip that was based on the code provisions. And we can see here that in terms of the pushover analysis that our capacity displacement are beyond the damage control drip as well as the demand drip for this direction. For the facade, we can see again here our idealized SDO curve. Somehow we had some difficulty in having a convergence for this direction, but we can see here that the damage control limit is still within the pushover analysis curve, but the demand drip is beyond this limit. However, when we conducted our initial assessment and benchmarking by taking the actual intensity experienced by this structure that is corresponding to the earthquake happened in the July 2022 earthquake, we found out that the drift corresponding to that demand is consistent with the damage control drift limit. So we can say that this drift limit here is still consistent with the actual observed behavior during earthquake. So the recommendations we had is that, of course, the demand displacement that was due to the earthquake is the one that causes the displacement of the walls. But we found out from our pushover analysis that if the walls were intact, that means if the properties of these masonries were intact, then these walls can accommodate those demand displacement introduced by those earthquake experienced during the July 2022 earthquake. However, due to the presence and intrusion of these vegetations, particularly the infiltration of the roots in the interior part of the wall, this is the 2-meter wall, masonry wall, that somehow reduces the capacity of the existing wall, and there was a clear presence of deterioration of the masonry wall, which then resulted to the collapse of the exterior part of the wall. Thus, what we initially introduced is to apply herbicides in order to eliminate the presence of vegetation in order to prevent further deterioration of the masonry wall due to this biological growth. So showing you here the picture of the condition before the application of herbicides, and on the lower right is the application of herbicides, which we actually formulated based on the chemical analysis that we conducted for both the clay brick as well as the lime mortar. So initial tests were also conducted prior to the implementation of this herbicide to the entire structure.
2 minutes, Doc Mac.
Yes,
you.
thank you. In addition, since you can see here that most of the damage were in the exterior part of the wall, and we need to reconstruct the wall, we actually conducted the chemical analysis and we tried to source out some materials that are compatible and consistent with the chemical composition of the clay brick as well as the lime mortar. We were able to successfully source it into a local manufacturer within the area, which is an original brick manufacturer in Ilocos, which still uses a conventional kiln in order to produce this clay brick. And we were able to coordinate and work with them in order to somehow reproduce the same type of brick that was used during the Spanish era construction of this church. So now the project status is the project is now ongoing. The reconstruction of this church is now ongoing. So thank you.
Thank you very much, Doc Mac, for keeping that time. No? Thank you. We thank all our speakers, no? And sorry for the very limited time. Again, to our participants, please send your questions at the Q&A box. No, our speakers are answering them. We will now proceed with the three reactions, no, from our three reactors. May I call on Dr. Gion from University of Glasgow, please.
Yes, thank you for the very interesting presentations. I really enjoyed them. I think it really shows how much we advanced the technology in terms of the assessment against seismic risk and also flood risk against for these individual structures. So as this shows us a great opportunity for a further advancement of our technology, I'd like to briefly mention about analyzing and making decisions on connected infrastructures like roadway, road transportation networks, and pipeline networks. And because I find that the analytical tools have been developed very much recently, but it doesn't seem that these analytical tools are being implemented in practice as much as for those tools that developed for individual structures. And I find three challenges to address to this end. The first one is the complexity of these tools because it needs additional system analysis. But I believe that if there's enough initiative from practice and academia, we can easily address this issue because I don't think these tools developed for individual structures are simple, but they are very actively implemented because of this good high initiative from industry sector. And the second challenge is the lack of prepared data sets. So we have not much data sets about this connectivity or connectivity about these road networks and their interaction for operation. And this is also something that we need to be prepared against before a disaster event, because it is already too late if we start collecting data when something happens. And the third challenge it would be the data that we collect during this disaster situations. So for example, in the Turkey earthquake this last year, we know that there was a substation closed down right after an earthquake, but we don't know how much it impacted the power supply in the region. And but we need to start collecting this kind of impact because of this connectivity of infrastructures so that we can better our models. But I think there is a good opportunity. So during this, for example, if we make a breakthrough in this way, then there is a lot of opportunities that we can make use of. So for example, after the Turkey earthquake last year, there was a big problem of this long-lasting disruptions in the water supply network, which created another problem of health issue for these already affected people. But then the problem was that all the pipelines were buried, and as Juanito mentioned, that we don't know all of these pipelines locations a priori, and so excavation had to happen. But the problem was that it took so long time to decide where these disruptions causes existed. But I think using these existing network risk analysis tools, we can make use of probability theory to make back inference from these what we observe on the surface. So we knew that where this unclean tap water was coming out, and we can back propagate this information to infer the most probable places of these disrupted pipelines, and we could have made the excavation process much more efficient. So we have this kind of opportunity. And so I hope that all these great advances in technology could be further advanced in this direction to address these connected infrastructures. Thank you.
Thank you so much, Dr. Jion. Let us now proceed with Dr. Jerry, the Green Climate Fund. Yes, please.
Hello. Good morning, good evening to all of you. I'm Jerry Velasquez. I'm from the Green Climate Fund. For those of you who don't know, the GCF, we are the financial instrument of the Paris Agreement. We're the largest multilateral climate fund. And we fund projects in developing countries on adaptation and mitigation. Climate resilient infrastructure is one such category. We provide about $2 billion in financing every year. If we look at the trend so far, I'll talk about financing because I think it's a very important topic that actually is that leads to the discussion today. I think last year there was on report about $200 billion in economic losses from disasters and about $100 billion of insured losses. It's the fourth time consecutive year that this has happened, and it's growing. Now, we did some modeling with Air Worldwide a couple of years ago, and we found that this is caused mainly not by climate effects, no, it's by development. So it's the concentration of people and economic activity and higher value assets in exposed locations. So what we're seeing is that there is this trend of concentration of valuable assets. And this is not a poor country issue, because if you look in the US, 49 million houses and about $10 trillion of property are exposed because they're in the coast. In addition, about more than 1,400 building permits are issued per day in the coast. And this is in the US. So you could imagine what happens in other countries. But it's not just extreme events like cyclones and earthquakes that cause economic losses, because if you look at public buildings, 46% of schools, 54% of health facilities, 80% of roads, and more than 90% of water, sewer, and power installations are damaged or destroyed in frequently occurring but smaller disasters, smaller floods, more frequent events, and so on, not the large and extreme typhoons and cyclones and earthquakes. So it means that we have two extremes to deal with these increasing losses. One, on one extreme, residual risk is sometimes so high that properties become uninsurable. You cannot insure them anymore because the premiums are so high. On the other hand, to maintain and deal with these extensive risks, we call them frequent but small, you need maintenance and operations, often very difficult to put into government budgets, for example, because often in government, it's very difficult to put budgets in something that you cannot see and calculate. So how then do we get about escaping this cycle of funding cost after an event? How do we go into investing in resilience and not investing in, reconstruction? How will that happen? The present trend, there is a perception that investing in risk, resilience, and infrastructure is not a very good investment because it's high cost and they cannot really see the resilience benefit. How can we turn this around? In higher cost infrastructure, what we need is to focus on not only on showing the immediate benefit, but also in lowering the operational risks. Because in higher cost, it is the operational risk that is in fact more disruptive. So I do believe that your work is very important because I believe that understanding risk is not well known. The typology and understanding of the layer of risks, especially in infrastructure, is not known. And you could see this in all kinds of infrastructure, in the kind of instruments that are deployed to deal with resilience of infrastructure. Although there's insurance for certain hazards, it doesn't exist for others. So there are perverse incentives, therefore, for constructing in floodplains because there is nothing that prevents people from doing so. So I do believe that there is much more work to do to understand risk, and we look forward to working with you. And in the GCF, this is one of the things that we do. We do provide a lot of financing for risk understanding, for investing in the the delta between business as usual infrastructure to resilient infrastructure, and also financing all of the barriers and all the risks that are involved, including policy, regulation, and so on. So thank you very much.
Thank you very much, Dr. Jerry. We will now proceed to Dr. Emma for you. Yes, 5
Okay,
minutes,
thank you
please.
very much. Yeah, thank you very much, Dex. First of all, thank you very much for inviting me. Thank you, Professor Dina and Professor Rafa and Dex. And thank you for all the excellent presentations of Dr. Oreta, Dr. Garciano, and Engineer Cunanan, and Dr. Asa, and Dr. Mendoza. The title of my commentary is Interrogating Infrastructure Resilience, Contextual Drivers of Exposures, Intersecting Vulnerabilities of Climate Change, and Building Capacities of Coastal Peoples and Communities in the Philippines. My basic argument is that, we have to infrastructure resilience, you have to put people and communities at the heart of coastal development in cities of the global south. We need to shift in our orientation in terms of looking at the intersections of hard and soft infrastructures. Here, I focus on infrastructure in coastal cities and communities, especially with highly exposed vulnerable populations to climate impact drivers, typhoons, flooding, sea level rise, saltwater intrusion, and the like. What do we need to do? I think, one, we have to understand the contextual drivers of risk and resilience. Two, we have to appreciate the transdisciplinarity and intersectionality of vulnerabilities in our building of capacities for resilience among our people. And three, underscore the intertwining of mitigative and adaptive approaches towards resilient coastal infrastructures to reduce the effects of climate impact drivers. Four, support the political, economic, social, cultural well-being of peoples and communities, especially for those whose livelihoods depend on healthy ecosystems, and be mindful of the intended and unintended consequences of coastal infrastructure. Here you have Maniena's model, which I think take into consideration basically the whole risk and resilience journey that we should undertake in order to bounce forward together. Because if we don't, then there are plenty of maladaptations happening around in our midst. There's a range of, coastal development, wherein I argue that we should put people at the heart of this public-private partnerships for community well-being. And I say that to put our, the heart of the infrastructural sense within the context of what I call public-private people partnerships and coastal resilience. And you can basically say you interact the physical infrastructure like seawalls, roads, bridges with the land use and building codes, wherein the implementation is really based on the local government regulations as they implement it or not implement it in partnership with CSOs, private sector, academic community-based organization. I think we have to pay attention to the intersections of vulnerabilities and intertwining aspects of hard and soft infrastructure. I think we argue here that we have to be science-based in terms of moving our people towards climate action. And number one, there's a Pareto principle, with power and numbers, and to focus on innovation and collaboration. But I always say, to collaborate, but we also have to navigate the intra and inter-systems of navigation in local, national, and knowledge systems. Here, this is the Metro Manila and Philippine climate change context. So you'll have here the projected coastal flooding in Metro Manila and Metro Cebu. Sea level rise is will be affecting 54 of the 81 provinces and 64% of 1,860 municipalities and cities. I will focus on, my recent work on Metro Cebu, which basically Metro Cebu have 12 cities and municipalities. And you can see here the flood hazard index of Metro Cebu, flood vulnerability under its lack of coping capacity and lack of adaptive capacity, and the normalized flood risk and temperature anomaly, And then you have to focus on the city demographics of Mandawi. And you'll see the location of schools versus hydrometeorological hazards, locations versus seismic hazards, and location of health centers with hydromet hazards. And this is the summary of the multi-hazard profile of the city and urban services. And you'll see how they're highly susceptible and vulnerable to these hazards. I will argue that adaptation and DRR measures across local governments, the commercial, industrial, vulnerable communities. This is based on our survey in Metro Manila, and now I'm starting this in Metro Cebu. And I really, if you look at it, there are so many initiatives, but as you can see, they are rather fragmented. So many initiatives at the household, community, and commercial, industrial, and city level, but they are rather fragmented. So I'd like to argue that we need a multi-scalar approaches to risk governance. One, there's a need to establish coherence in introduction of structural
1
and
minute, Doc
non-structural
Emma.
measures of adaptation. And then between sectors across time and space, resilience frameworks need to be designed to address dynamic interactions within sectors and scales along different division-making levels. And I'd say gender, generation, and social geographies need to be contextual to reflect conditions in both formal and informal economies. And I'd say to know more, you can look at our website in resilienceToolkit.ph and coastal cities at risk in the Philippines. So everything you can download from our website, just acknowledge the source. And I say my message to policymakers, science tech leaders, innovators, professionals, research scientists, and practitioners. If you want to go fast, go alone. If you want to go far, go together. Thank you very much.
Thank you very much, Dr. Emma, for you. Okay, please, if you have questions, you can key in them the Q&A. Our panelist will also try to address them immediately or before I turn this over to Professor Dina for the special session. There is a question, for example, for Doc Mac. How were the roots that have penetrated the walls removed? You'd like to answer it live? Yes.
Yes, for the roots, actually, we initially applied the herbicides. And after a week or so, we let basically the vegetation dried up, which is then easy for us to pull out the roots. So that's the only time we remove them. So we never force to remove any part of the vegetation. So if we cannot pull them, we just trim them. So that's what we did.
Doc Mac, what's the software used in the analysis?
Sub 2000 nonlinear. Thank you.
Thank you. Of course, the webinar will be available on the UCL website where you registered, but also on YouTube. No, so we will send them to all the registrants on a later date. And Professor
So
Dina,
we are
I
trying to
give it
quickly
back to
read
you.
we are trying to quickly read the questions to see. I think there is a very interesting one, and I just put it there for anybody to answer really. What are the potential risks and threats to the infrastructures of the academic institution, given the situation here in the Philippines? How likely are these risks to occur, and what would be their impact on the institution's operation? And I think when we are talking about academic institution here, we are talking largely about school and, not just university. So maybe Alessandro or Andy, would you like to answer this question? Or Juanito, for that matter?
Yes, I can answer that one.
Please.
Yeah, of course, these hazards that we have across the country are all posing danger to all our structures. Right now, although it has not been passed, and it was a question raised earlier, that the National Building Code is being updated. The Philippine Building Act is under legislation, and is now pending before the Senate of the Philippines. And hopefully, upon approval, this will make a very big change on how we look into the institution. So the academic institutions will be classified as essential facilities, and therefore the design requirements will be different from the past. Like the one in my presentation, the school buildings were supposed to be designed as capable of for relocation purposes or evacuation purposes. So there is additional factor of safety required for them as a response to these hazards. Also, the hospital buildings, the Department of Health requested the ASEP few years ago to craft a possible circular for them to raise the factor of safety for hospitals beyond what is in the code. But as a response, the ASEP said that the maximum requirement for the essential facilities in the code is enough, is quite enough for the hospitals to resist all these hazards that we have in the Philippines. So I think this, of course, if not addressed, will have an impact in our institution. But as I mentioned in the presentation, the government, the national building official through the DPWH required all structures with high occupancy to be designed not just as ordinary structures but as essential facilities. So essential facilities are required to be resilient in terms of requirements.
And I would
Can I
like
add?
to, sorry, yes, please.
Yeah, the threats to school are usually earthquakes, strong typhoons, and flooding. And this would result in, well, no school for the particular, depending on how extensive would be the damage to a school. So depending on the location of the school, depending on its exposure to these elements, then that would pose as a threat to the operation, not only operation, but of course, the school children going to taking classes in the schools. And I think but the government, I think, is doing something right now, especially with respect to the big one in Metro Manila, where they're retrofitting schools starting from 2 kilometers from the West Valley Port up to as far as 60, 70 kilometers. And they're retrofitting these schools through the Department of Public Works and Highways. Thank you.
That's great, thank you. And it's a pity that I think Dr. Velasquez has maybe left the connections, but I was just wondering whether we have a measure of the level of funding that his organization is providing to reducing risk and increasing resilience in the Philippines. Maybe Dexter, you can answer that.
No, but he has another meeting and he was saying, please, no, we can send the questions here and he'll be glad to answer it through email.
Okay, then that's perfect. So we will ask him and then we will continue this conversation. As we are now just about 12 o'clock, so without further ado, I think it would be good to introduce Dr. Pierre Mars, who's a lecturer at the Yulin University of Science and Technology, and will briefly report us on the Taiwan earthquake in Yulin. Please, Pierre.
You hear me?
Yes, we can hear you perfectly. Thank you.
Wonderful. Yeah, just about school. Yes, this morning I received a message from my school, and they ask every teacher to inspect the room around his office and to check for beams, columns, and any kind of damage, and to report. So, and there are forms which are provided, and also some reference documents which are sent.
Thank you for this insight.
Yes, so I am going to speak about Taiwan, so about the earthquake, and yes, so good morning UK and good evening Philippines. So I have no official involvement in what
Can
I am
you
going to
share your
present.
screen, maybe? Or
Yeah, yeah. No, I didn't share.
yes, we can
Do you
see.
see it?
Yes.
Okay, good. I have no official involvement, so it was a personal initiative, and so I wanted to go one day on the site and to take a photograph and make observation. And basically, also, it's not my my main area of research. I am a professor in the Department of Cultural Heritage Conservation, so I was expecting also to find problems with cultural heritage, but I met mostly problems in concrete buildings. And yeah, I wanted to do that very fast because I had the opportunity to go, and I wanted to gather first-hand observation because I think this personal experience and direct contact with the situation is important. So Hualien there is aware of danger. So I don't know, it looks like kids drawing. I think they are really kids drawings. You can see there someone which is helping maybe the leaning building or the Tower of Pisa, and with the Eiffel Tower, or I don't know what. So Hualien is a dangerous place and a difficult place to access also, because Taiwan, there is a chain of mountain in between, and so to arrive to Hualien from the place where I live there, Doleo, which is quite close to Gigi, where there was an earthquake 25 years ago, is not easy. The road across the mountain are closed, and anyway they are very long, and so I had to go by the south. In the place where, in my office, that was the only damage that I encountered. So one of the arch resist, the other one collapsed. I learned after, when I came back, also that the chimney there in a town close to the place where I lived fell down. And this morning I was with the students also looking at adobe house in the neighborhood, and they are damaged also. So that's probably going to be my interest in the following weeks to see problems of vernacular architecture. So there you can see the kind of global risk that in Taiwan, and Hualien is there, and they have everything. So they have a tsunami, earthquake, typhoon. So this is the most dangerous place to be in Taiwan. And I am there since 18 years, and this is the strongest earthquake I ever felt. And usually the earthquakes, which are come quite regularly, they are coming from the area there from the East Coast, most of them. So this is actually, so there is a central range of mountain, and then close to the coast there is another range of mountain, and you have a valley in between, and Hualien is at the end of this plain. And so this is the south of Hualien. This is the kind of scenery you can see. It's a very beautiful area. This is the road in the mountain, which is crossing the mountain. That's a photo which was taken already some time ago, because this road is closed, and this is the place where many people, where quite a few people died also, so which were trekking in the mountains. And that's from Google. This is the north of Hualien, and there you can see that the mountain is really falling directly in the city, in the sea, in the ocean, and at the end there you can see Hualien also. And this road is cut because one bridge collapsed, and so this road is completely closed. So I came from the south, and I follow the road which is following the coast, and each time I saw some feature of interest and some damage, I stopped and I took photograph. So a few areas there, I saw that there were rock which fell down on the roads, and but the road is open, and so they are already all accessible. And more incredible, also that was one day just after, so 24 hours after the earthquake. The road which were cracked by the earthquake in different area and in different spot along this south road were already repaired or under repaired. So that was extremely fast and efficient. There are quite a few interesting bridges on the way. On the south, they are all open. I took some footage, and this bridge there, so maybe it's a little bit damaged. I don't know. I noticed that when I was back. This maybe is a little bit. There is a crack, but I'm not so sure. But for the other, I didn't see anything major on the way in relation to bridges. So that's in the north, just before the closing of the road, and that was a huge landslide. And here you can see the dejection code. So this is on the north coast. Yes, so I'm not going to, I don't have much time, so I'm not going to speak very much about data, but I guess you will have access to the PDF after. Yes, so yes, so some friends asked me also about liquefaction because they were interested about that. I don't think that I didn't see any problems related to liquefaction that I could identify. Maybe a few years ago there were problems in the Avon, and so that may be the case also this time. The earthquake was quite strong, so I guess it's too small for you, but there, this is the spectra, and the maximum there is 14 meter per second squared. Yes, and so I wanted just to walk around the street, and to each time I saw a little trace, maybe a tile which fell down, or a building completely collapsed, just to take photographs. So this is, I have more photos that you are going to see today, but yeah. So one of the first things which was visible, it was the building that probably you saw in the newspaper also, this building. So that building, I couldn't approach it because obviously there it is blocked by police, and only journalists can come a bit closer. And so that was how it was before. And so actually most of the problem that I observed, they were related to a weak first floor, first story. That's a building which completely collapsed. So this is before, and this is now. But actually, those are the dramatic pictures. But I was very surprised because, especially I was there an afternoon and then the morning after. And the morning after, I walked for something like 3 kilometers before I encountered the slightest little problem. Life is really directly continuing, and there are many buildings which do not present apparent damage. That of course, it's just by walking along the street. So I'm sure I missed some. So for instance, I saw a school, and from the outside everything was fine, but that was one of the place which was damaged inside. So the most common damage that I observed actually is they are non-structural, and they are kind of tiles which fell down or were cracked in different places. And so that I saw quite many. There were also quite a few wallets like this which fell down. I saw probably 5 or 6 like this. And so that's a building that possibly you didn't see, which is very damaged, and there that was sad and interesting also to see all the people which were evacuated and trying to bring their belongings to safety. And yeah, you can see that's kind of the typical damage that you can see in the most critically touched buildings. So it's usually in the top of the columns of the first story. And yeah, so that's another one also. But you see, the owner didn't seems obliged to move his motorbike, so he's quite confident in the safety of the building. So that's another one also. So there, yeah, I am not really a concrete specialist person, but the density of rebars seems to be quite high. And actually, yes, I have another photo about that, but so this is not in the quantity that you get most of the problem, but possibly more in the matrix of the concrete. And yeah, and in the general design of the buildings, especially the old one, because after the earthquake of 25 years ago, the codes were completely changed and improved. Yes, so that's another building which had an interesting damage and unusual one. Also, it has an horizontal crack which run all along the first floor there, but the side walls and the rest of the building seems undamaged. Yeah, I observed also quite a few buildings in which, especially the one there on the right there, I saw in a few buildings this kind of retrofitting which was implemented, and that's this one is on a hospital. And so I know that Dina and probably many of you are also interested in schools. And so in Taiwan, after the earthquake of 25 years ago, there was a big programs of retrofitting of schools, which was implemented. Yes, so that's just some image of new constructions. So where you can see a bit the kind of technique which is used. And so, yeah, very often, so I have to say I was surprised how well all the buildings resisted, because often when I look at the quality of the concrete, I am reminded that I am not in Switzerland, and it's not always very, very beautiful, and there are a lot of knit pool. I don't know how to say that in English. Aggregates which are very visible. So the matrix is not always very, very good. But yes, and sometimes also I would have expected a building of this kind not to resist very well to the earthquake, but apparently it was not damaged. And then in Taiwan, a bit everywhere, there are galleries all around the streets, and many of these galleries, they have columns, and the columns are hidden behind panels like this. And I am thinking that's probably not very easy after to see if some of the structure were damaged or not. So that's all what I wanted to tell you. So basically, is that yeah, I was expecting much, and that's what you can read in the newspaper. Also, I was expecting a much more stronger effect of the earthquake, and I was happily surprised to see that it is the buildings resist very well. And I look since then also I look at the evolutions of the codes in Taiwan, and in Taiwan, every time there is an earthquake in Taiwan or elsewhere, also there are some adaptation which are made to the code to make the building more resilient for the next earthquake. So thank you very much for the invitation.
Thank you very
And,
much,
that's
Pierre.
all.
Thank you for this first-hand witnessing and report from the streets of Hualien, which we would have otherwise been able to reach. I have just one question about this. You mentioned that the code has been updated every time there is an earthquake. Now, is the code updated for new builds, I assume? How consistent is the program of assessment and retrofitting of existing building? Because as we have seen in these images, at least the buildings that for which you have shown damage would appear to be quite a few years old, so probably more than 20 or 25, referring to the let's say last big one in 1999, and then the major changes to the code, but also how consistent is the program of assessment and retrofitting of public building, but also ordinary commercial building, like some of these are, because I think this has been a question that has been asked several times today throughout our webinar in order to improve resilience. So that I think the point of view of what's happening in Taiwan, given the low level of damage, is very appropriate.
My understanding is that there is, and yeah, don't quote me on that, but there is a big difference between the official buildings, the schools, and the governmental building, for which there was a very organized retrofitting, which was implemented, and buildings like this one, which are private buildings. And so for this one, I guess it depends of the initiatives of the owner.
So there are no specific enforcement.
No, I don't think there was enforcement, but don't quote me on that. But I would be surprised. But if you look at the new constructions, you can see that really the design of the building changed completely after the earthquake of 1999. So in the new buildings, there is a strong difference. And actually, so this one is a hotel.
Mm-hmm.
This one, yeah, it looks like an apartment buildings. This one also, and yes, so that's so the main one also. So that's also an apartment buildings. And on the other hand, if you see the this one is a hospital. This one, if I remember well, it should be a bank. Mm-hmm. I guess the one which have more money, or the one for which it's really critical infrastructures, they were probably forced to retrofit their structure.
Thank you very much. I wonder if there is any question from our panelists.
Yes, let us second time. I don't see the question. No, yes, I have to see if no.
So in which case, if there are no questions from our panelists or from the audience, then I think with 20 minutes delay, we are closing this session. Dexter, maybe you would like to give a few words of closure?
Yes, we just want to thank everyone, especially our speakers and reactors for this session. We really thank you for sharing your expertise and your experiences and your time. I'm sorry, I have to remind you of the time limit all the time, but we hope no you are able to deliver your message very well. Thank you also to UNESCO Chair for organizing this session. And we'd like to ask the audience to please join us in the succeeding webinars. The link is posted there. And for ASEP, there is also an upcoming SMART conference. The organizers are also here. Doc Mac or Doc Gigi, you'd like to say something? When is that? So many are from the Philippines, no? Doc Gigi?
Yeah, thank you, Dex. We'll just have a short plug-in. We'll have the SMART 2024 conference in Cebu in Bay Hotel, and Professor Dina is one of our speakers, and
That's
also
true.
speakers from Japan, from Taiwan, and it will be an interesting conference, and we hope we can see you on the 22nd to 24th of May in Cebu
Yes.
City.
So thank you very much. And here is the link to the evaluation form so you can help us improve our next activities. Your certificate will be sent to you once you satisfactorily answer the questions there. The evaluation form or link will be open for about 6 hours only, no? So about 12 or 1 in the Philippines. So if you have questions, please kindly send us an email. Thank you very much, everyone.
Thank you.
Back
There
to
are
you.
Thank
still
you.
many questions to be answered, and we will certainly organize follow-ups webinar to this very interesting webinar from the experience of increasing resilience in the Philippines. Thank you all again. And I think, Dexter, you wanted to take a pictures of all of us?
Yes,
So
for
that's your
those
opportunity.
thank you. So I ask everyone to please to open your camera and smile. Maybe Raf, you can also do your own, but I'll have it from my computer. Okay, smile. That's good. Thank you very much.
Thank you.
Thank you.
Thank you.
Bye
Thank
bye.
you all for
Good night.
attending and delivering such interesting talks. Thanks all. Thank you, Emma, Juanito, and Ramirez,
Thank you.
which I didn't,
Yeah.
Rodolfo, which I didn't met you before. That's
Yes.
great.
See you in May, Dina.
Oh, that
Thank
would
you
be
very
nice.
much. Thank you.
Thank you.
Thank you all.
Thank you. Bye-bye.
Bye bye. Bye.
Thank you.
Bye-bye. Thank you.